Today we're solving quadratic equations by factoring. To warm up, let's factor these expressions to review what we know about factoring. So when we look at number 1, notice that all of these coefficients are divisible by 2 and that this leading coefficient is negative. So what I want to do first is factor out a negative 2. And now I've got 6x squared plus x minus 15. And I want to factor that further, breaking down this trinomial into two binomial factors. So I'm going to use that AC method. I'm going to multiply 6 times negative 15, which gives me negative 90. I can put that at the top of my x. And then there's an understood 1 in front of this x. So I put 1 at the bottom. And then I ask myself what would multiply to negative 90 and add to 1. And the answer is 10 and negative 9. So that's how I will split up that x term into a 10x and a minus 9x. Then we factor by grouping. So when I look at these first two terms, I ask myself, what's the greatest common factor? And that would be 2x. So when I factor 2x out of these first two terms, I would get 3x plus 5. Then I move on to the last two terms, and I ask myself, what's the greatest common factor? Minus 9x minus 15, and that would be minus 3. If this is a minus sign right here, I have to factor out a negative. So factoring out the negative 3 would give me 3x plus 5. So our common binomial was 3x plus 5. And then their greatest common factors were 2x minus 3. And then remember that we factored out that negative 2 from the beginning. We got to make sure we bring that down and include that in our final answer. Number 2, notice there's only two terms. So if there's only two, ask yourself, is it the difference of squares? So we are subtracting, so it's a difference. 25x squared is a perfect square. 81 is a perfect square. So remember, that factors into like the sum and difference of the two square roots. So the square root of the first term would be 5x. Square root of the last term is 9. So that factors into 5x minus 9, 5x plus 9. Recall our zero product property. If two things multiply together to equal 0, then one of them must be 0 or both. Solve quadratic equations by factoring. First, you need to have your equation into standard form. So standard form has your x squared term plus your x term plus your constant all on the left, and then it's set equal to 0 on the right-hand side. So once it's equal to 0, then you take your expression on the left and you factor that. So that's breaking it down into the linear factors. And then once it is, you go from writing it as the sum of three terms to a product of two binomials. If these two expressions multiply together to equal 0, one of them must be 0. So you set each factor equal to 0, and then you solve each equation separately. So with number 1, we've got x squared plus 7x plus 12 equals 0. It is already in standard form for us. So step 1, done. And next step is to factor it. When the leading coefficient is 1, those are our easy ones. So we split up the x squared. And then we see that we have to multiply to positive 12 and add to positive 7. So we must both have plus signs there. Then we ask ourselves what multiplies to 12 and adds to 7. If you're thinking 3 and 4, that's correct. So now we took this expression and wrote it as a product. So in between these two parentheses, that's multiplication right there. So if these things multiply together to equal 0, one of them must be 0. So x plus 3 equals 0 or x plus 4 equals 0. Now we have two equations, solve them separately. So this equation I would solve by subtracting 3 from both sides, and the second equation I would solve for x by subtracting 4. So our answers are x equals negative 3 and negative 4. Number 2 is not in standard form. So to get it in standard form, we want it to equal 0. So to get this to equal 0, I would subtract 9x from both sides. So now I'd have x squared minus 9x minus 10 equals 0. The leading coefficient is 1, so those are the easy ones to factor. I'm going to split up my x's. And then the last number is a negative 10. So to multiply to be negative, we know we have to have a plus and a minus. And what would multiply to 10, negative 10 and add to negative 9? That would be plus 1 and minus 10. Set each factor equal to 0. Then we solve each equation separately. In this first equation to solve, I would subtract 1 from both sides. In the second equation, we would add 10 to both sides. So we get x equals negative 1 and x equals 10. Number 3 is not in standard form, so I need to get it equal to 0. So I would subtract 5 from both sides. So now we have this quadratic trinomial equal to 0. The leading coefficient's not 1, so unfortunately it's not one of the easy ones. I'm going to factor it just by guessing and checking because this is a prime number here. So 3 is a prime number, so I'm going to break it up into 3x and x. And then I know the last numbers have to multiply together to be negative 10. And so I'm going to start with the factors of 10 that are closest together, which would be 2 and 5. Now I do have to check and make sure that my outside product plus my inside product gives me 13x. So our outside product here is 15x. The inside product is negative 2x, which would add to 13x. So I did guess correctly. So these are my factors. Now that I have factored it, I will set each factor equal to 0. And then I will solve. So in this first equation, to solve for x, I would add 2 to both sides. And then I get 3x equals 2. And then I would divide both sides by 3. 2 divided by 3, it doesn't divide evenly. Just I'm going to leave my answer as a fraction of 2/3. For the other equation, I would subtract 5 from both sides, and we get x equals negative 5. In number 4, to write the equation in standard form, first I'm going to distribute this x. So that gives us x squared plus 3x. Then we need it to equal 0 to be in standard form, so I'm going to subtract 70 from both sides. So we're getting x squared plus 3x minus 70 equals 0. So I do have a quadratic with a leading coefficient of 1, so those are the easier ones to factor. Split up your x's. And then the last numbers have to multiply together to be negative 70. So I know I have to have a plus and a minus. And then what would multiply to negative 70 and add to 3? Positive 3. So I must have a minus 7 and a plus 10 because those multiply to negative 70 and they add to positive 3. Set each factor equal to 0. Then solve your two equations. So the first equation, we would add 7 to both sides. And in the second equation, we subtract 10 from both sides. So we're getting x equals 7 or negative 10. Number 5, we have to distribute the x and distribute the 5. So x times x gives us x squared. X times 2 gives us 2x. Then distributing the 5 times x is 5x. So we combine that 2x and 5x to get the 7x, and 5 times 2 to get 10. So that's just our FOIL method. To get it in standard form, we need it to equal 0. So subtract 40 from both sides. And then to factor that, the leading coefficient is 1. So we're just going to split up our x's and ask ourselves what multiplies to negative 30 and adds to 7. So it's not 1 and 30. It's not 2 and 15. Oh, 3 and 10. So we want it to be plus 10 and a minus 3. And set each factor equal to 0. And solve each equation separately. Number 6, we want our x squared and our x term to be on the left. So I'm going to subtract 12x from both sides. So we're getting x squared minus 12x equals 0. So we only have 2 terms. So if there's only 2, ask yourself, is it the difference of squares? In this case, it is not. But we can just factor out a greatest common factor. So x squared and x both have an x. So if I factor that out, I get x times x minus 12. Now that it's factored, I can set each factor equal to 0. So either the x equals 0 or the x minus 12 equals 0. This one's already solved for x. To solve this equation for x, I would add 12 to both sides, and I get x equals 12.